measurement teams or data scientists or even academics, they often focus on precision of measurement. They want the most precise measure, the most accurate measure, the most unbiased measure, right? And I think a good marketing organization can answer the question why. So the first thing I ask them, I want more precise measurement. I asked them why. What will a more precise measurement enable you to do? What decisions can you take? And actually, in my experience, 80% of the time, I don't get an answer.
Hello everyone, I'm Rajeev Nair, co-founder and chief product officer of Lifesight. Today's episode is very special. I'm joined by Professor Ron Berman, associate professor of marketing at Wharton School and a scientific advisor to Lifesight. Professor Berman's work spans digital marketing, experimentation, attribution, AI, informed by experiences across technology, venture capital, and academia. Professor Berman, welcome to Humans of Measurement. We are delighted to have you here with us and super excited to begin this new chapter of collaboration with you.
Thank you so much, Rajeev, and thank you for hosting me, and I'm excited to join.
So let's start with your journey itself. So your career has taken you from computer science to venture capital and eventually to marketing science and academia. So what led you along this path, and how have your experiences so far shaped the kind of marketing questions or marketing science questions you choose to study today?
It's a bit of a random, it's not like a very well-planned path, but I was a software developer for quite a few years. And then I was an MBA student and was had a part-time position in a venture capital firm initially. And one thing I noticed, in a VC firm, what you do is you usually analyze the teams that come in and propose a new venture, and you analyze the team, the technology, and other things. Most of the times the challenge was not in the technology, like they could always make it work. Teams sometimes had challenges, but the go-to-market was always a challenge. So very often, especially the kind of technologies I saw, etc., which was Web 2.0 at the time, they could make it work. They had a very hard time finding customers for it. Kind of when I wanted to get a PhD and I wanted to combine my computer science knowledge and maybe other things that are related, let's call it to more mathematical, maybe scientific style research, I was thinking of a field. I actually never applied to marketing. I applied to finance because it's a more, let's call it mathematical field, at least in my mind it was. I didn't know too much about marketing, etc. When I did my PhD in Berkeley, Berkeley is known to be quirky and unique. So they had a thing that they said, well, if you apply to finance, sometimes we admit you to marketing. And when I asked them why, they said, because your research was interested on the boundaries on the firm, on interactions between consumers and firms and competition. And that's actually under marketing, usually in the business school departments. So why don't you read some research and take a look what you like? So I had options to go to finance. I had options to go to marketing. I started reading the research. Finance was indeed, let's call it more mathematical and required probably more mathematical tools. But I liked the interaction between firms and customers and things like that. And because I wanted to do research on startups initially and things like that, I thought marketing would make more sense. So this is how I ended up in marketing. I even thought I'll go later back to industry and maybe be either, I don't know, a data scientist, a founder or something like that. And that's a longer story how I reached academia later, but that's how I ended up in marketing. My kind of belief was wrong. Marketing is a much more, let's call it mathematical scientific field that most people think. Yeah. It's very interesting because it's hard to analyze customers and firms, and the data is messy and the decisions are unclear and nothing is very precisely measured and under your control. And I think we still have a lot of both research and applied challenges we need to solve, which to me makes it very, very interesting.
And we also believe that now we are in a phase where we want a more seamless handshake between finance or corporate finance and marketing teams. And that's essentially the place where we are currently operating to sort of enable these two orgs or these two functions within a business to sort of help align their conversation that they're having and talk in similar language. So with that, I'd like to shift to the central theme of today's conversation, which is about the state of marketing measurement itself. So based on what we see, almost every organization describes itself as data-driven. So marketing teams have more data, dashboards, attribution reports, and even models today than ever before. But producing more measurement outputs does not necessarily mean that these decisions are better or more scientific. So the question to you, Professor, is based on your experience, from your vantage point, what separates an organization that truly practices measurement from one that simply generates a large volume of metrics? Or in slightly different words, what according to you are the qualities of a good marketing measurement practice?
If you talk to a lot of marketing, let's call it measurement teams or data scientists or even academics, they often focus on size measure, the most accurate measure, the most unbiased measure, right? And I think a good marketing organization can answer the question why. So the first thing I ask them is, I want more precise measurement. I asked them, what will a more precise measurement enable you to do? What decisions can you take? And actually, in my experience, 80% of the time, I don't get an answer. And partially because there's a team who measures and gives the numbers to a manager, and the manager makes a decision. The team and the manager, I don't know if they're not aligned, but they don't consider very carefully this two-stage process. So how does the measurement affect decision making? A very common thing you will see is that data science team has a goal of being more precise, more accurate. The numbers go to the managers make decisions that even ignore the numbers, etc. So I think a good organization is one that aligns those two and almost does it, we call it backwards induction. When we analyze game theory, it does the opposite, is they think, what data do I need to change my decision? And if it doesn't change my decision, I don't need this data. Because if I keep on the same decision again and again, then I might as well just not collect the data. And they are able to identify the focus of both the measurement and the data collection to align themselves to either verify their current decision or change their decision. So this is what I'm always recommending in my classes, to organization, to everyone. We have this intuition that if I have the more precise and accurate number, I'll make better decisions. And we have some research that shows that it's sometimes correct, but not always. And I think identifying the difference between sometimes, when, and now is what makes a marketing organization.
It interestingly brings us to the topic of causal inference and experimentation. And I'd like to use one of your papers as a segue into this topic of experimentation, which is the paper on false discovery in A/B testing, where you analyzed, 2,700 plus experiments and came to this surprising conclusion that even among results declared statistic, say 5% level, roughly 20% of the experiments reflect no true underlying effect. And I'd like to explore some of the implications of that finding, particularly from the perspective of being a marketing measurement vendor. But first, for our listeners who might not be familiar with the paper, so if you could summarize the central idea and findings in your own words, that would help, and we could take it from there.
So if you do some statistics, you're being taught to do something called hypothesis test that is supposed to guarantee that if you say, let's say you run an A/B test and it turns out that A performs better than B, it can be for two reasons, because of noise or because there's an actual difference. You're being taught that your hypothesis test will say A is better than B. In the weird case where A is equal to B, which means the difference is because of noise, it will only happen 5% of it. That's usually kind of the way we think about it. So this, we call it a false positive. You say, well, 5% false positive is not that high, so I'm okay making a mistake once in a while. Well, it turns out this is not the question you usually want to answer when you do an analysis, because what this thing answers is, among all of the experiments that have a zero effect, how often will I get a false positive? What you want to answer is, for this experiment where I got a significant effect, what are the chances this one is coming from a false positive? Because you're looking at a specific experiment. You're not like saying, I'm running all of the experiments in the world or I'm comparing them. Well, if you know some Bayesian statistics, it's actually a different question. So the first question was, among all sorts of all of experiments, what are the chances of a false positive? And this one is, among, given this statistically significant result, what is the chance of a false positive? They answer different things. The numbers are higher if in your population of experiments, there's a lot of zero effects. So if you're running experiments that most of the time they don't do much, the statistics that doesn't guarantee you will get 5% false positive, you will get more. And these are called false discoveries. It's called a false discovery because a discovery is when you have a statistically significant result. So first of all, from a managerial perspective, what we're being taught to kind of answer about false positives is actually not what we usually care about to make a decision. I care about this specific A/B test, not about the universe of A/B tests. Well, if this specific A/B test, you want to know if it's false positive or not, you need to look at the effect size and then other things, and you can compute a number, which is called the false discovery rate, that will tell you what is the probability this one has. So this is what that paper does and analyzes, etc. What we do in this paper is we take a large population of A/B tests that were run on the Optimizely platform and estimate for those who were discovered as statistically significant, how many of those are probably false discoveries. And as you said, it's about 20%. It's pretty high compared to the 5% you would care about. For marketers, that means that people are often trained to focus on, I run a hypothesis test, and if it's significant, then I deploy. And if it's not significant, I don't deploy. But that 5% might be incorrect if you don't do a false discovery, either control or analysis. And why? Because you run a lot of experiments at once. When you run a lot of experiments at once and you test many, many hypotheses at once, the chances of false discoveries increases. So I know this was very, very technical, but let's talk about the implications. Okay. So some of the implications are from that research are twofold. When you're using statistics like hypothesis tests, you should test, are they measuring what they care about for decision making? Okay. If false discoveries matter more than false positive for decision making, you should change your metric. It's just so different. The second thing you should think about is, does the context of my firm or my experiments affect what I should expect to get? So I'll give you an example. I'm running a lot of A/B tests, and let's say those A/B tests do very, very minor changes in the color on my website. I should not expect to see big effects, right? Yeah. Well, that means I'm basically inflating the chances of having a false discovery. And you can actually estimate that from data from a lot of your experiments. What is happening now is slowly companies are kind of realizing that, and they're saying we have a portfolio of A/B tests that we ran. We can actually do a false discovery analysis and control and make sure we have less and less and less false positives.
In our practices, we typically focus on designing experiments which have good statistical power. But essentially what we are telling here is, even after making those designs, if your interventions are not big enough, you might not create detectable lift at the end of the test, right?
When you say good statistical power, that depends on how big the lift is, right? So they're designed to detect a specific lift. And if you're experimenting with things that are not expected to generate a high lift, there's a much higher chance that your statistically significant results are going to be false discoveries versus not. Because you don't really know the true lift before you run the experiment. Your analysis is based on an assumption that you will achieve some lift, and often that doesn't work.
Because now on the measurement solution provider, there's a lot of this pressure around being able to run fast experiments, right? So the question is, can you run experiment for just 2 weeks and have meaningful learning from that? And there's also this new philosophy which says we perhaps need not even run an experiment. We could perhaps infer things just based on observational data from the past and all of that. So our perspective has been slightly more conservative. So we think experiments should not be trifled with, right? Because for us, experiment is just one of the tools in the whole process of measurements, right? So you have got models on the other side. And the way we think of experiment is you have to put utmost rigor into running these tests, because the outcome of the test is not just the learning about that intervention, because you are eventually planning to bring it back to the model. So for example, if you are running a test on YouTube by scaling up YouTube, and when you have meaningful learnings from that, bring it back to a market mix model. And by calibrating YouTube in that model, you are essentially adjusting for all the other variables also, right? So you could potentially discover something about Meta and Google and their interaction and all of that just by running a good YouTube test. So because of that, we are of the opinion that experiment has to be run in a proper way. There's no value in hacking experiments, right? It has to be as rigorous as possible, because your entire measurement stack is anchored on that learning.
So actually the answer is more nuanced than that. There is value in hacking experiments, but it's very, very specific. If the experiments do not influence learning in the future, it's just about, I need to pick between A and B, but what I discover is not going to teach me something about the future. I'm not going to change, just pick between A and B. It is actually optimal not to have very large or largely powered experiments. You can run short experiments that pick the best between A and B. And let me give you the intuition, okay? When you pick between A and B, you only care about making a mistake, let's say if A is much bigger than B and you somehow pick B. But if they're really, really close, you're like, whatever, I'll pick one of them. It's not worthwhile to wait until I have a lot of sample and I move on, okay? So the opportunity cost of having a larger experiment is more expensive than determining. And then it's actually better to hack it and run it quickly, etc. I have another paper, it's relatively famous in academic circles, called Test and Roll, which kind of says you don't need hypothesis tests. Okay, you wanna choose the sample size to be proper, but it's much smaller than the one that you would get prescribed by hypothesis. But what you said later says, but a lot of these experiments inform our learning later. They update models, they update where we try experiments, etc. And actually, my recent research shows that then the false discoveries really matter. So we're going back to kind of how we started this podcast. Depending on the decision you'll make, this is the data you collect and this is the tool you will use, right? So if you want long-term decisions, false discoveries really matter. If you really want short-term, I need to pick a color, green or blue. It's not like gonna determine we're gonna be pretty close. You can hack it. You can do a small, even then there's an optimal sample size, but it can be much smaller and much faster than the properly size.
So essentially what you're telling is we can run shorter experiment just to get a directional gauge of what's right. But if we have a assumption that these two options that we have are not vastly different from one another, then we just need a directional read. But if you want to sort of truly quantify the actual lift, and if we think that there exists an actual lift between the intervention and the control, and that's where we have to be more rigorous with the test.
You put it in very nice. If you just care about picking the best one, you don't care about how far they are from one another, you usually do a relatively small experiment. If you really care about by how much, okay, and sometimes you do and sometimes you don't, then you want a properly powered and sized experiment. So you can think about it the following way. Hacked experiment will just tell you A is better than B than some probability, okay, but I don't know how much better. A properly sized experiment will tell you A is better than B in 11% plus minus 2%. Right? So that requires much more sample size. Sometimes you care about just knowing which one is better, and sometimes you care about I need to know by how much, etc. Both are experiments, both are validly run, but how you size them and power them is very different depending on the decision you make.
So general observation from our side, from the industry, perhaps you might disagree, is that so when we look at say internet companies, product organizations, so we are very experiment minded. So we want to test out a lot of things. Even when we build products, we start with MVPs, take it to the market, get feedback. So which in a way is an experimental approach to building products. But what we observe is in the marketing org, it's slightly slower when it comes to adopting experiment as a practice. And we believe it's because of the influence of attribution as a process that today exists in the marketing organization. But would like to hear your views on this, on how marketing org could be more favorable to adopting experiment as a key technique in their analytic process.
First of all, I think they are applied in different contexts because when you apply experiments and technology, you often have control over the sample much more conveniently than in an advertising campaign, etc. Let's say randomization and geolift, etc. And also, it's much easier for you to generate changes that will have high lift. And when you have high lift, you can run a smaller experiment. So you're in an environment where experimentation makes sense. In a marketing environment, two things happen. First of all, generally, most marketing effects are pretty small. We do it on many people, but the effect itself is very, very small. So you need gigantic samples, a lot of costs, right? Running an A/B test on a website often doesn't cost you anything additional. You just randomize. Running campaigns actually costs you money, right? And the second thing is the availability of observational data is much, much bigger. So you have a trade-off. I have all of this observational data that exists. Why not analyze it? Why do I need to stop the normal flow of the business and start running A/B tests? So I think these are, let's call it objective reasons why people in marketing, let's say advertising and marketing measurement, run A/B test less. The other thing is, let's say in a product management decision scenario, you run an A/B test, you pick one, you move forward. In marketing, it's not very clear what to do with the result. So suppose you run an A/B test this week and it tells you your Google channel is slightly better than the Facebook channel. What do? Do you change the budgets? Does it even apply for next week? You will need to rerun another experiment in 2 weeks to verify it. So because the follow-up decision is not kind of like a one and go, or you need to constantly measure seasonality, etc., it also makes the experimentation results much harder to act on. So I think both of these play a big role. Finally, and this is another thing, in order for experiments to work well, what you should do is you should run experiments that are kind of have big changes, big creatives, big strategies to have a very large lift. On a website, you can run it for a day or two, you break something, you go back. In a marketing campaign that has reputational effects, people are really afraid to take very bold kind of choices, but that makes experimentation hard. So it's almost like experimentation makes sense if you have a lot of money, if your environment is very static, and you're willing to take very big risks. Not that many organizations like that exist, right? For example, for smaller businesses, they basically never have a sample size large enough to even know if their advertising works or not. And this is why they prefer observational.
Just shifting our gears a bit here to discuss what I would call the AI in the room, right? Which these days is, the elephant in the room, right?
Yes.
This is AI agents and things around that, right? So we see that AI agents are moving beyond answering questions. Right? They can now recommend budgets, design experiments, modify campaigns, and do a bunch of different things. But before an agent is allowed to influence or execute these decisions, what kind of context should these agents have, and what scientific audit trail is needed to understand its assumptions, its reasoning? What guardrails should these agents be given, right, before they can even recommend the right budget and sort of act on behalf of marketers in making these budget changes? So have you thought about some of these implications?
So it kind of goes, you asked me the first question, what is a good marketing organization? I'm like, it's one that can answer why. The agent should be able to answer why, and he should be able to give it the reason why. So I think what a lot of organization hope is that I never thought of the why, or I kind of did it intuitively. I'll use kind of a general purpose AI agent, and they will do better decisions for me than I did, or at least the same level. I don't know why they would do it, because unless you align them to your organization, they're going to do probably some best practice from the industry. Okay, but we don't know that it's the best practice in the sense that it's actually best. We know people do it, but we don't know if it's best. We don't know what it's allowed for. We don't know how it's measuring things. So I'm thinking a few things. I think one way is an organization should probably use their past decisions and data to fine-tune a model to fit, assuming they make the right decision and they're happy with it, to fine-tune a model to fit their goals. The second thing they can ask agents, here's our decisions. Can you figure out our strategy and explain it to us? And then you can tweak and say, no, I want to do something else, etc. And I think another thing, but that's again, this is usually applies for very large organizations. You want to A/B test with AI agents. You put people to manage a big portion of the budget, and you give an AI agent to manage maybe a smaller size of the budget, and see if it makes better decisions in the sense that you can actually measure the difference, okay? And the difference should be either and of course in the revenue or the cost, that's fine. If you cannot measure the difference and it doesn't save you anything and gain anything, maybe you don't need it. If you can measure the difference, then I think organizations should do that. So I think to summarize, you want to have an objective function like everything else that says, this is what I'm planning to gain from using AI agents. Like answer the why for AI agent. Why do I use an AI agent? To save money or to make better decisions? And if you can't, be very careful when you deploy them.
Yeah. So that objective function perspective is very unique in some ways, because we have been mostly thinking in terms of building a measurement context layer, right? So one thing that you referred to, can we have a record of past decisions that you made? What business constraints sort of governed those decisions? What were the evidence that was available to support those decisions and things like that? And measurement could sort of provide or feed into this context, and the agents could perhaps tap into this. So we were mostly thinking in terms of a measurement context graph, but the idea that whether it's actually driving some business outcome, right? So that in itself has to be sort of objectively measured.
Quantified, right? Exactly.
Yeah.
I guess the question is, how will you know your agent is making the right decisions? You need to think in advance, and sometimes it's very soft. Explain to me the decisions, and I agree, and I press OK. Sometimes it needs to be hard. It needs to be measured. What you mentioned about the data layer, you can do it in two ways. You can just say, I'm going to give it all of my information, and it will kind of figure out how to learn. You can also say, we'll give it also my past decisions, and we'll say, this is what you should mimic or replicate. These are my preferences, and then you can optimize over those. Okay, and this is kind of where the research is going today. We're giving agents past human decisions, and they learn kind of through reinforcement learning, etc., to say this is what this person or this organization cares about, and we can optimize those. So I think it has a lot of promise, but you need to very carefully think, what am I doing, and what is the goal of what I'm doing with those?
I'm done with most of the serious questions that I had for today's discussion, but I've got three what I call the wind down questions. Right? So the first one is around current set of research interests that you're following. Right? So what's your current intellectual curiosity? What are you focusing on currently when it comes to your research? Could be directly related to marketing or anything else.
It is marketing related. I am a marketing professor. I'm very interested in A/B testing, what the concept of learning, which is what we kind of discussed very briefly. A lot of the research on A/B testing looks at it as kind of a one-time decision, maybe among many, many parallel decisions, but one time. It doesn't look necessarily how it affects the future. So I already kind of have a working paper in the works about how you should think of hypothesis tests and making decisions when you know your current experiment affect your future experimentation. And the outcome will be a new sample size or decision-making framework for using A/B tests. You still run the same A/B test. How you make decisions with the data changes. So this is some of my newer research. I'm looking also on research on this idea that, different measurement approaches yield just different numbers. You run MMM, you get 20% ROI. You run attribution, you get 30% ROI. Which one's incorrect? The answer is none of them are correct, but none of them are wrong. And there's smart ways to use both results to make decisions, and this is what I'm working on. And I have some research, I think in marketing, reinforcement learning has a lot of potential. it hasn't been used very, very often. Like it's been done in many, many other settings. And kind of this is where I think a lot of my future research will go to. So that's about it. We write papers slowly and carefully, so we don't do a lot of things at the same time. But these are like the three themes I'm currently spending most of.
The second question is, are there any recent AI tools that you came upon which got you hooked into it?
So it's funny because when you say recent, for me, recent is 6 months ago, but in the AI world, it's probably last week. So, I've started using, let's say, Claude very, very seriously about 6 months ago. And in the past, you can think my workflow was we were doing the math either with one software ourselves, we were doing the coding, of course, ourselves, but with some other software, the data analysis sometimes in another, and writing the paper in another. And what's fascinating with Claude is, first of all, the research process is you feel like you're working with a research assistant, you have questions, they answer, etc. What I love the most is simulating stuff with Claude. Because in the past, every time you had an idea and you wanted to run a simulation, it would take hours or days and they get the results, etc., etc. Now I can describe to you a project. I said, hey, I have this idea. I'm thinking of doing that and that and that. Has someone written a research paper about that? 5 minutes later, now. Okay, here's the model I'm thinking of. Formalize it. So it formalizes the model. Okay, write a simulation and test this, and this. And within an hour or two, you kind of know if you have what we call the smoking gun of a new research finding. There's a lot of distance from there to, of course, a research paper, etc. But those smoking guns were used to be so hard to find. Like you try this and you try this and you had this and this software, etc. And now it's pretty good.
We close every conversation with a book recommendation. Do you have a book recommendation for our audience?
It's funny because I only read in my life one, let's call it novel, which involved marketing. And that's called Pattern Recognition. It's by William Gibson. Okay. I mean, it's kind of a sci-fi. I don't know if you've heard of it.
No, I'm not.
Okay. It's modern times. It's from 2003. It's kind of sci-fi, but it's not exactly. And it's a person whose job is something called a cool hunter. She goes around the world and looks like at emerging trends and identify new brands and stuff like that. But she gets hired to identify a mysterious poster of videos on social media. It turns out to be misinformation. It's kind of very forward-looking to our days, etc. So there's some kind of a detective plot. But the nice thing and the reason I like that book is that because it's about both marketing and sci-fi, which I like, it has a lot of these tidbits of knowledge about brands and history and marketing, which if you're into this field, it's kind of fun to learn. And it's, of course, just an interesting story. So I highly recommend it.
I was expecting you to recommend something very academic, but you have a novel.
I do have those as well, but, I don't know if people want to read a lot of books with math, etc.
Just to highlight one point. So in the last episode, I was talking to Professor Kuhn Powell. We were discussing this book called Decision-Driven Analytics, right? And so this specific point sort of comes up in a lot of conversations that I have with people from the academia, that before you think about analytics, think about the decision that you want to make, or what you want to do or what you want to pursue depends on the decision that you want to take, right? So just going back to that specific book we were discussing in the discussion.
It's interesting that it's only now converging, but basically a lot of the measurement paradigm came from statistics or computer science. Let's call it decision making in a business context was really the focus. Other decision making was, but now it's kind of in vogue because of the AI, because of reinforcement learning, because of loss functions, etc. It's all about regret and decisions. And I think it ties up very, very nicely the measurement paradigm and the decision making paradigm. But it also makes us discover new things. It discovers a lot of the stuff we were so focused on in the past, maybe are less important, maybe are more important. So I'm very excited about the new innovations in marketing measurement and generally in what we do in business school and research, etc. But it's also sometimes disappointing because we're like, oh, what we thought was the right thing to do for the last 20 years. Turns out it's not as right. We need to change it. But that's how research is. That's why I like research.
Thank you for joining us today. This has been a great conversation, but this is also the beginning of a much broader collaboration. We are incredibly pleased to have you as our first scientific advisor, and we look forward to bringing more rigor and scientific discipline into our products and into our research. So thank you again for doing this podcast with us today, and we welcome you to our research council. Thank you, Professor.
Thank you so much, and thank you for hosting me.